Alright, so we should be on page 183, and if I remember correctly, you guys should be on example 2, or problem 2. Okay. So, yesterday with these problems, what is the first step we really need to take with a problem like this? So we're looking at number 2. So if you need to look back, what should we do first?
Find the factors of 3 and 18.
Okay, why 3 and 18? What are those two numbers? I hear one.
The constant.
The constant and the leading coefficient, exactly. So for this one, we need the factors of 3 over the factors of 18. Alright, and we can go ahead and list those with the plus and minus. So for 3, it's plus or minus 1, plus or minus 3. And for 18, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18.
What are you going to ask my friends?
Nothing for the office today. You're welcome. Have a good day. Alright, so we have all those factors of 3 and factors of 18 listed out. And now we can make them all into our fractions. So, we start out 1 over 1. So we just have plus or minus 1. 1 over 2, plus or minus 1/2. And we'll keep listing those out. And just like yesterday, once we get with the 3, some of those numbers simplify to the same number, so we don't have to rewrite it. So we have plus or minus 1, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6, plus or minus 1/9, 1/18, 3, and 3/2. Are we okay with that so far? Same as yesterday? Alright, and I should have reminded you, if you didn't already, you need a calculator. So if you want to, go ahead and grab one now, or if your partner has one, you can look at your partner's. But and once you get your calculator, go ahead to the y equals button, clear whatever's in there, and you can add this problem in. The window for now, we could leave it -5 to 5, and we can look and see how it looks, see if we can view it. As we move on, we don't necessarily have to write this graph down, but as we're practicing this, you can write it down if you want to. But if you have the calculator in front of you, you don't really have to. So it's up to you if you want to actually draw this in your notes so you have it. Referring back to it, it'd be nice to have it in your notes. So I'm going to draw it here. And we can see on the left side, where does it seem to cross the x-axis? About where? Go ahead. Yeah, about 1.5. So I'm going to put a dot here. Well, -1.5. And does it touch the x-axis anywhere else? Marie? Yeah, it looks like it comes and touches it and then goes back up right around about 1/2 or so. So we can say that it's close to 1/2. If you looking closely, looks like it's a little less than 1/2. Do we have any numbers that may be close to a little less than a half out of our possible roots? Yeah, we have a third, so I'm going to put that closer to a third because it looks like it's just a little less than a half. So if we draw this, it's going to look something like that. Alright, so like you said, the possible roots. Out of our possible roots, what two do you think we should focus on? Marie?
Negative 3 halves and positive 1/3.
Negative 3 halves and positive 1/3. Those are the ones that we're going to try. Now remember, this problem, I don't know if it was mentioned yesterday in this class, we have all of those possible roots. And what process do we use to check the two that we just said are possible roots? What process are we going to go through?
Synthetic division.
We're going to go through synthetic division. If the remainder is 0, that means it's a what? It's a root. Yeah. So, all of these numbers up here that don't work, we would not get a 0. So, before there was a calculator, so Mrs. Bauer mentioned in a few classes yesterday, if you did not have the calculator in front of you, so you were not able to view the graph, you would actually have to check each one of those numbers with synthetic division to see which ones are the roots. So there's 1, 2, 3, 4, 5, 6, 7, 8, but they're each plus or minus, so you would have to check 16 numbers to see which ones are the roots. Using the calculator, we narrowed it down to these two. Now we're going to verify that these two are the only two. Okay. So, like you said, next is synthetic division. So let's just go ahead and start with the negative 3 halves. And we'll set that up with the synthetic division. So for the negative 3 halves, after you complete your synthetic division, you do get a remainder of 0. Now we want to check the other possible root, 1/3. What possible ways can we check this with synthetic division? What can we use for the next division, right?
You can use the answers with that.
Yeah, you can use this 18, negative 12, and 2, because the quotient should also be the factor, or the possible root of 1/3. So we can use this one, or you can use the original. But this answer here has less numbers, so we're going to use it. So we'll use the 18, negative 12, and 2, and we're going to do this for the 1/3. Getting close to the bottom here. Alright. And when you perform that synthetic division, you also get 0 on the bottom, or your remainder. So they both are roots. So now here's something we actually need to think of. So let's start writing out our answer. The roots are negative 3 halves and 1/3. But if we look back at the original, what are we missing here? Go ahead.
1/3 doesn't have plus the 2.
Exactly. How did you know that?
Because you can see it at the
Yeah, if you look back at the graph that we drew, or back on your calculator, when it comes down to that 1/3 that we found is a root, it bounces off and goes back up. So the multiplicity has to be even. In this case, it has to be a 2 because we have a degree of 3 in the original, and we know that negative 3 halves is a root. So we have negative 3 halves and 1/3, but 1/3 is with a multiplicity of 2. with a multiplicity of 2. Now I know yesterday there was quite a few examples in this one today. Are you guys feeling a little more comfortable with this? Alright, so if you want to, go ahead, number 3. I'm going to start working through it slowly, but if you want to try it on your own, and we're going to check and see if we have the same answers at the end. So go ahead, you can get started on example 3. Has everybody done copying for example 2? Okay. When you list out the factors, you should have 10 there before you figure out what your possible roots are. This one might be a little tricky. Really pay attention when you graph this one. Really pay attention to the graph. Before I go any further on the board, is anybody to this part, or can they help me out what the possible roots are? Go ahead. Okay, I like -3/4, and I do like 2, because those are close. But if you really look at that graph, what do you think's happening?
It crosses right over, so it has 2 x-intercepts, so also -5.
Yeah, if you look really closely, it's not stopping at the x-axis. If you look, it's bumping above it just a little bit. It doesn't stop there. So it's actually coming up, touching, going over, and coming back down across the x-axis. So it's actually touching there twice. So we know that -3/4 is close, but what else is close if it's coming back down through? She already mentioned it. What is it? -1/2. Now, if all 3 of these do work as our roots when we check the synthetic division, does that make sense for the original problem? Yeah, because we have a degree 3. So now we can check these 3 roots with our synthetic division. It doesn't matter which order you check these in. I'm going to start with 2. I'm going to write over on the left because I ran out of room, but I started with 2. I'm going to check negative 1/2. Negative 1/2 checks out. And lastly, negative 3/4. Negative 3/4 also checks out. Bring down the 8, multiply by negative 3/4, we get negative 6, and those add to 0. So our roots for this problem are what? Right?
Negative 3/4, negative 1/2.
Negative 3/4, negative 1/2, and 2. And the original degree of the problem was 3. Alright, so we have 3 roots. Very good. Any questions on those? That's the last problem in this section. We are going to move on to the next section today. So we need to finish copying that, and then we're going to go to page 187. Any questions before we move on? Alright, sounds good. Alright, so we're going to continue what we were doing in that section. So we're still checking for our roots, but we're going to add a little bit more to it. So if we start at the top, real roots can be one of 2 types. So what are 2 types of numbers that are real numbers? There are positive and negative, not quite what we're looking for. What are numbers that can be written as a fraction called? Starts with an R.
Rational.
Rational. So the first one's rational. And that is some number divided by a number. So rational, number divided by a number. Or, if it's not rational, it's irrational. Exactly. Anybody have an example of an irrational number? Pi. Pi is irrational, and square root of 2 is also irrational. So those are a few examples. So we're going to have roots that can be rational or irrational. So far in the past section, all the answers we found have been what? They've been rational. So we're going to get to some irrational answers. Alright, so for the first problem, we have this h of x function. 3x to the 4th minus 8x to the 3rd minus 12x squared plus 24x plus 9. And the graph is already pictured for you, so you don't have to necessarily put it in your calculator. It's already there. We want to list 3 things about this graph that make sense after investigating it. So take a minute, look at that graph, and what are 3 things, if you think back to when you were learning about graphs, that make sense about this one, or 3 things that we can find out from this graph.
Roots match the number with the multiplicities, like they believe that the question has 4 and there's 4 multiplicities.
Okay, so one thing is, it's a degree of 4, so we have how many roots? I mean, that's what you're getting at, 4 roots, yeah. So one thing is it's a degree of 4. So So that means there are 4 roots. Marie?
The constant matches where it crosses at the y. So
Very good. Yes. So the y-intercept we see crosses at 9. Well, that's what the constant is. So constant term is 9, which is the y-intercept. So the constant term is 9, which is the y-intercept. Very good. Those are 2 things. One more from this graph. But the picture makes sense if you look at the original function. Marie?
the graph is even and positive.
Yes. So it's even degree. So what do we know about a graph, the picture of a graph, when we have an even degree function?
It rises on both sides.
Okay, so if it's positive, it's going to rise on both sides. If it's negative, it's,
Both fall.
yeah, both will fall. So let's write it's even degree and I'm going to write a plus sign, positive leading coefficient. So positive leading coefficient, that's what the plus LC. So this means the graph rises on both sides. It's an even degree and a positive leading coefficient, so the graph rises on both sides. So those are the 3 things that we can tell. The degree is 4, so there has to be 4 roots. The constant term is 9, so that's the y-intercept, that's where it crosses. And the even degree and leading coefficient, so the graph rises on both sides. Very good. All right, so next question. What conclusion can you draw about the 4 roots of the function of h of x? Explain your reasoning. So, what do we know about these 4 roots from looking at the picture? Okay, they're all going to be real. How many are we going to have?
4.
Okay, we're going to have 4. How many times does it touch the x-axis?
Well, each of them has a multiplicity of 1.
Yeah, so it touches 4 times. They each have a multiplicity of 1, so we're going to have 4 roots, or 4 zeros. So, the graph has 4 zeros. So the roots are real. So all the roots are real. 2 of them are what, and 2 of them are what? Marie?
2 positive and then 2 negative.
Yep, 2 positive, 2 negative. So 2 are positive, 2 are negative. Exactly. We have these 2 positive ones over here, and we have these 2 negative ones over here. Everybody's okay so far? Kind of a review of some of the material we've had. Alright, so like we used in the last section, we're going to use the rational root theorem. So we're going to find the roots and tell whether they are rational, irrational, or imaginary. So let's make a list of the rational roots for the rational root theorem. So what is our constant that we need to make or list our factors for, right? Yeah, so we need plus or minus 1, plus or minus 3, plus or minus 9. Factors of the constant go on top. Now we need the factors of what on the bottom?
Leading coefficient.
Yeah, and the leading coefficient is what? Yep. Plus or minus 1, plus or minus 3. Now, if we list them out, go ahead. Plus or minus 1, plus or minus 1/3, plus or minus 3, plus or minus 9. Alright, from our list here, which ones seem to be ones that could possibly be on our graph? Marie?
3 and negative 1/3.
Okay, so we see that 3, I'm just going to list them down here. 3 could possibly be on there, and negative 1/3. So we see, if we look back up here, the 3, it looks like it goes right through the 3. Negative 1/3 looks like it goes right through there. And do we have any other numbers that look like this one or this one yet? No, we don't have any numbers that are close. So let's start with these two, and we'll go from there, because we know these two are really close. How many should we have at the end? How many roots? Okay, we should have 4. Right now we only have 2. So let's check these two and make sure they are correct. So, synthetic division, I'll start with the negative 1/3. 3, negative 8. Negative 1/3 worked. Now I'm going to try 3. And 3 also worked. So we know that 3 and negative 1/3 are 2 of our what? They're 2 of our roots, yes. Now, after we've gone through the synthetic division twice, this result over here with the 3, the 0, and the negative 9, what is our highest degree in this one if we were to write it out? This 3 would have a degree of what with it? A degree of 2. Because over here it started with 4, the answer had 3. When we went through the synthetic division again, we should have a power of 2 here. So what we're going to actually do on the bottom, and you've already answered this question, you just divided a degree 4 function twice, so your resulting polynomial is a quadratic. Power of 2. So let's rewrite it as that power. 3x squared minus 9. If we look, there were no x's, 0. There was just x squareds in a constant term. And that's equal to 0. Is this something we know how to solve, or we can get x by itself? Yeah, so let's go ahead and get x by itself. Add 9 to both sides. Divide by 3. How do I get rid of x squared? Square root. And when I have a square root, I have what in front of the square root for the answer? Plus or minus. So what is this answer telling us? Marie? The roots. Yeah. Yeah, one of the roots is an irrational number, but it's a plus or minus square root of 3. So these are our last 2 roots we were looking for. We have the 3 and the negative 1/3, and here we have plus or minus square root of 3, so this is our other 2 roots. So the roots are negative 1/3, 3, square root of 3, and negative square root of 3. So those are the roots of that function from the top. Any questions before we move on? All right. Alright, so now we're going to deal with something just a little bit different. So we have a function at the top again. It has a degree of what? Degree of 4, very good. Alright, so what do you notice about this graph that does not make sense based on the degree?
There's only two roots visible.
Yeah, we can only see visible or physically right in front of us, we can only see a root here and a root there. So, what do we notice? It's a degree 4. But f of x only shows 2 roots. Alright, so now if you look down at the next question, what conclusion can you draw about the 4 roots of the function of f of x? Explain your reasoning.
All the roots are possible, rational, or irrational. And then two roots would have to be greater than -5 or less than -5.
Okay, so if all the roots are rational or irrational, they would have to be greater than the -5 or 5 because we can't see them on the graph. But if we're saying these are the only 2 graphs, we can see everything we need to see. It doesn't touch the x-axis anywhere else. We see 2 there. What does that tell us?
Two of the roots are imaginary.
Exactly. 2 of the roots must be imaginary. So, 2 roots are real. So, 2 must be imaginary. Two roots are real, so 2 must be imaginary. Now we're going to go about this the same process we did before. So the next thing we need to do, you guys already know how to do this, start listing the possible rational roots. The constant was 4. So we're going to have plus or minus 1, plus or minus 2, and plus or minus 4. And the leading coefficient was 2. So you guys should be really good at that by now. And we have 4 numbers there, but they're plus or minus, so we actually have 8 possibilities here. Of those 8, which 2 should we try, or which 2 seem or apparent by looking at the graph that are most likely the roots? Go ahead, Marie.
1 and -1.
Yeah, we're going to look at -1/2 and 1. And again, you know how to check these. Let's go through the synthetic division again. So the -1/2 works. Now I'm going to try the 1. The 1 also worked at a remainder of 0. So once again, very similar to the problem we just completed, This is a degree 4. We just found 2 roots. So our result is a what? What should that blank be? Our result is a quadratic. Yep, just like the previous problem. We divided twice. Okay, so we know it's going to be a quadratic. So we can rewrite it just like we did with the previous problem. We get the 2x squared from right here. There's no x's. There's a 0 there. And the 8 is our constant. So 2x squared plus 8 equals 0. Now solve it. 2x squared equals negative 8. X squared equals negative 4. And I'm going to take the square root. I get plus or minus square root of negative 4. But can I actually do the square root of negative 4? So what do I get as an answer?
Plus or minus 2.
Exactly. So I get x equals, I still have the plus or minus. Square root of 4 is 2. And the square root of negative 1, because we could actually separate this. This could be plus or minus square root of 4, square root of negative 1. When you multiply the inside, you get the negative 4. So the square root of 4 is 2. Oh. That square root of 4 is 2. And the square root of negative 1, she already said, is I. So how many roots do we have right there? We have 2 right there. And how many did we have from up above? 2. So we have our 4 roots. So the roots are... What are the roots? Roots are negative 1/2, 1, 2i, and negative 2i. Now I know we did three different types of problems, but they're all using the same methodology to solving them. Do we have any questions about those, or feel okay with those so far? So tomorrow we're going to continue on with this idea, but we are going to expand on it again. We're going to have another answer that we're going to have to solve in a different way. So we're going to go through the same steps, synthetic division, but we're going to get to a point where we get down to this section, but we can't actually solve it for x. So we're going to use another method to actually find the last 2 roots that we need. Okay? All right, that's it for today, guys.